Hello, future engineers. Welcome to my YouTube channel. If you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way of keeping me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also don't forget to subscribe. For the thrust shown below, construct the influence lines for the bar force of AL, KL, CK, CD, and EJ. So we have here the thrust. Then for AL, let's draw the free body diagram. And this is the influence line for reaction at A. Let's have the shortcut 1. There are 6 panels, so 1 divided by 6 is 1/6. So the reaction increases to A by 1/6 from 0 to 1, or from 1 to 0 at A. Then for AL, the free body diagram should look like this. And remember that when X is 0, the load is at A. So therefore SAL is 0. But when the load is at any other position, then summation forces Y equals 0. SAL times 4 over square root of 41. By the way, the slope is 5 horizontal, 4 vertical. So square root of 41 would be the hypotenuse. So SAL times 4 over square root of 41 plus RA equals 0. So SAL is negative square root of 41 over 4 times RA. And this is for x greater than equal to uh, greater than 0. Because when x is equal to 0, SAL is 0. So SAL is equal to 0 for x equals 0. So let's now construct the influence line for SAL. So when x is 0, it is 0. When x is 5, this is the value 5, 6. So negative square root of 41 over 4 times 5, 6. That's the maximum negative value. And we are only interested of this value. Negative 1.334, then 0 at x equals 30 meters. So this is the influence line for SAL. Next for KL. KL is this member here, so the free body diagram. Let's consider section 1-1 and let's consider forces to the left of section 1-1. So this is the free body diagram. To derive the force of KL, we sum up moments about B equal to 0. So in general, the imaginary load is at x from A, then this is 5 minus x. So summation moments about B equals 0, SKL times 4 plus RA times 5 equals 1 times 5 minus x. SKL therefore is 1/4 of 5 minus x minus 1.25 of RA. This formula for SKL is applicable from 0 less than equal to x less than equal to 5 meters. Beyond 5, so we remove the contribution of the unit load. It's no longer part of the free body diagram. So SKL would be negative 1.25 of RA for x greater than equal to 5. So when x is 5, because this is 0, so negative 1.25 of RA, and negative 1.25 of RA is equal to negative 1.25 of 5/6, and that is equal to negative 1.042 in decimal. And when x is any other value, because it is negative 1.25 of RA, it is a linear function and it is decreasing because RA is decreasing. So we just extend, then 0 at G. So that's the influence line for KL. Then for CK, this is CK. So this should be the sectioning. So let's consider forces to the left of section 2-2. So this is the free body diagram, and our equation would be summation forces y. So summation forces y, Ra minus 1 minus SEK equals 0. So SEK is Ra minus 1 for 0 less than equal to x less than equal to 5 meters. Beyond that, the unit load 1 is no longer on the free body diagram, not part of the free body diagram. So remove it, so SEK would be Ra for x greater than 5. So in particular, when x is 5, Ra is 5, 6. So 5, 6 minus 1 is negative 1, 6. Then when x is 10, this is now formula Ra, and Ra is 2/3. And then we connect it to G, 0 at G. So that's the influence line for CK. Next is for CD. This is CD, so we consider forces to the left of section 3-3. So free body diagram should look like this, and our equation will be summing up moments about J equals 0, so that these two not named members will pass through J. We'll have no contribution about moment about J. So summation moment about J equals 0, SCD times 4 plus 1 times 15 minus x equals Ra times 15. So SCD is 3.75 Ra minus 1/4 of quantity 15 minus x. And this formula is applicable for 0 less than equal to x up to 10 only. So for 0 less than equal to x less than equal to 10 meters. Then beyond 10 meters, for x greater than 10, the unit load is no longer part of the free body diagram, so remove that. SCD becomes 3.75 of Ra for x greater than 10. And sorry, for x greater than equal to 15. Then for x greater than 10, that's not important because the next panel point is at D, and we are only interested of the ordinates when x is 10 and when x is 15. So when x is 10, this is the formula, 3.75 of 2/3 minus 1/4 of 15 minus 10 is 5, so minus 5/4. And that value is, when x is 10 is, when x is 5, it is 5/8. Substitute in this formula, 3.75 of 5/6. When x is 5, R is 5/6. Then minus 1/4 of 15 minus 5, or minus 10/4. So you get 5/8. When x is 10, 3.75 of 2/3 minus 1/4 of 5, you get 5/4. When x is 15, this is 0, so 3.75 of 1/2 is 3.75 1/2, 1.875, and that is 15/8. Then beyond that, it is a linear function. It is decreasing, so we just connect to 0 at the other end. So that's the influence line for CD. Then for EJ, so this is EJ. Let's consider forces to the left of section 4-4, and we'll just use the figure shown. So slope is 5 horizontal 4 square root of 41. So the unit load will be placed anywhere at the distance x. So therefore this distance is 15 minus x. 15 minus x. So the equation is summation forces y equals 0. RA minus SEF times 4 over square root of 41 minus 1 equals 0. So SEJ is equal to square root of 41 over 4 times quantity RA minus 1. And this is applicable for 0 less than equal to x less than equal to 15 meters. Beyond that, the unit load is no longer part of the free body diagram. So you remove this one here. So it is square root of 41 over 4 of RA for x greater than 15 meters. So we are now ready to plot the influence line of EJ. So when x is 15, so when x is 10 first, 2/3 minus 1 times square root of 41 over 4. So that's when x is 15. This is the formula. RA is 1/2. So 1/2 minus 1 times square root of 41 over 4 in decimal. This is supposedly square root of negative square root of 41 over 8. So in decimal, negative 0.8004. Then when x is 20, square root of 41 over 4 times 1/3 is square root of 41 over 12. In decimal, square root of 41 over 12 is 0.5336. And it is 0 here. So that's the influence line for AJ. And we will call this x1. So this is 5 minus x1. Then by similar triangles, x1 as to square root of 41 over 8. This is square root of 41 over 8 equals 5 minus x1 as to square root of 41 over 12. Cancel out square root of 41, then we have 8x1 equals 60 minus 12x1. So that means x sub 1 is 3 meters. Therefore, this is 5 minus 3 is 2. If this is 3 plus 15, so the distance of this point where SEJ is 0 is 18 from the left. And its distance from the right is 12 meters. 2 plus 10. So that's it for this problem.